Okay, so in this question, we've been asked to draw some vectors to scale. So just before we start that, just some quick information about what a scalar quantity is and what a vector quantity is. So things you'll have covered at school. But a scalar quantity is basically anything that doesn't have a direction associated with it. So across here you can see some examples of each scalar and vector quantities. And so some of them in everyday English, it's not very clearly differentiated which is scalar and which is vector. But and the first example up here is, for example, distance and displacement. So when we're working in science or engineering, distance is a scalar, and so it would be enough to say, look, I've traveled 10 kilometers, for example. So that's a scalar. Whereas if you were talking about a displacement, you'd have to say, okay, I've traveled 10 kilometers, and you'd also need a direction. So it might be north, for example. Similarly, speed and velocity, so kind of used interchangeably in everyday English, but in science and engineering, speed is a scalar quantity, so you just need to say, so it's essentially just a magnitude. So you might travel, let's say, on a bicycle, you might go at 15 kilometers per hour. But if you were talking about a velocity, you'd have to give both the speed, so that's the magnitude of the vector. So the speed, so you'd have to say 15 kilometers per hour, and then you'd have to say which direction you were going in. So it might be so 30 degrees clockwise from north or something like that. Or you might give a bearing or something like that. Okay, so some other stuff that's a little bit more differentiated. So mass, it can never have a direction associated with it. And so a mass would be your 10 kilograms or something like that. Now weight, on the other hand, so the equivalent weight would be 100 newtons. So remember, you're just multiplying by 10 roughly, so this is just approximate, 100 newtons. Now, usually for a weight, we wouldn't say any more because it always goes in the same direction, but if you've got the Earth again, for any object, it's not very well drawn, but the direction of weight, its weight as a force, is towards the center of the Earth. And so usually we don't say that, but it would always be downwards. So if we're going to be careful, we'd say downwards. Now, rather than having to write out the magnitude and direction every time you talk about a vector, so for each one, we've got a magnitude, we've got a direction. Rather than do that, often we'll just draw these things to scale, and that can be helpful because your scale diagram is often very useful for checking the answers that you get from other methods, more accurate methods. So the disadvantages of just doing it by drawing them out and to scale is it's not very accurate. The advantage is it's usually quite easy, and it's a very useful way of doing a quick check on your results. So let's just quickly have a look at how you draw your vectors to scale. It's probably something you would all be able to do anyway. So the first one, we've got a force of 300 newtons, 30 degrees anti-clockwise from the positive x-axis. Okay, so there's a few things to unpack in there. The first thing is we've talked about an x-axis. So when we're drawing our little diagram or scale drawing, we want to just sketch what direction we're assuming for x and y. So usually x is horizontal, y is vertical. It doesn't have to be. So x horizontal, y vertical. And so we're going 30 degrees anti-clockwise from positive x-axis. So just thinking that through, clockwise, same direction as a clock, anti-clockwise. So we're going anti-clockwise from positive x-axis. So we're going that way, and we're going 30 degrees. And then we want to just draw a line to represent the magnitude, and we're going to do it to scale. And so we've got 300 newtons. I'll just do 1 division as 10 newtons, so that'll give me 100, 200, 300. I should have done that in the thicker pen, just to show that this is our vector. Okay, so often on the sketch, just so someone doesn't have to measure it with their protractor, we'll just tell them what the angle was by drawing it on the sketch. So we'll just do a little reference line in the x direction. And this is 30 degrees. And then we'll usually write the magnitude on as well, so save you measuring it with a ruler. So that's 300 newtons. Okay, next problem. Displacement of 2 kilometers, 120 degrees clockwise from north. So this time we're not talking X and Y, we're talking northeast, southwest. We'll just do this small so that it's okay, usually enough. When you're in an engineering drawing, you'll just mark north with an arrow. But often you'll just do, just to show it's a compass. Mark like so. So we're doing 120 degrees clockwise from north. So let's look at how we can do that. So that's at 90 degrees at the moment. So we're going clockwise from north. So this way. So now we're going all the way down to 0. So that's 90. And we want to go 120, so we need to go another 30. So that's the direction we want to go in. We want to go 2 kilometers. So probably I'll do 10 divisions for half a kilometer. So you're going to go half, 1, 1.5, 2 kilometers. We're drawing that one to scale. Right on the magnitude. Do a little reference line. Now, because they've told us from north, we'll just do a reference line to north as well. And then we'll mark on our angle. 120 degrees. Okay, velocity of 3 meters per second, inclined at 20 degrees to the horizontal. So C. So incline means we start at, incline means start at horizontal. And we're going 20 degrees upwards from there, so incline from there. 20 degrees. And we're doing 3 meters per second, so I'll just do 10 divisions is equal to 1 meter per second. 1, 2, 3 meters per second. And this time, don't really need to do extra. Horizontal is just horizontal. So we don't need to, for example, for this one, we needed to show where X and Y was. This one we needed to show north was, but this is horizontal, we don't need to show that. So we'll just mark on our reference line. This is 20 degrees. And the magnitude of that vector, we need to show our direction. The magnitude of that vector is 3 meters per second. Okay, so that's them. So for each, when you're drawing a vector quantity, you're basically just drawing an arrow. The length of that arrow is scaled to the magnitude of the vector, and then we're just showing the direction as well. So every vector quantity has both a magnitude and a direction.